So in WellTest, we have a number of different unconventional tests available to us. Today we're going to have a look at the mini frac test. So let's go ahead and select that. And we're going to go and import our flow and pressure data, which is all contained in this one file. We do that by identifying the first row of data we wish to import, and then identifying each column of data by specifying the data type and the units. So we're going to go ahead and specify, bring in the date column, the clock time, casing pressure, and our injected water rates. Okay, and here we can actually go ahead and name our data and give it a start time, which it pulled off from the first line of data for us automatically. Okay, for this particular example, we don't have any additional data we wish to append. And we've already imported our pressures and rates, which were all in that one file. So we don't have any additional data we need to import at this time. Now the next step will be to go to the Data Management tab. Now in the Data Management tab, we can go ahead and do any sort of synchronizing, merging, smoothing, or filtering to prepare our data for analysis in the next step. For this simplified example, I uploaded a case that had our pressures and rates in one file, which were already synchronized. So we're gonna go ahead and do the filtering at a later step. So we're gonna hit next here. And at this point, we would be asked to remove any unnecessary data points at the beginning or the end of the test. Again, this data set has been cleaned up, so we don't have any data where we're pulling the gauges after the test or dropping the gauges down at the beginning of the test. The next step would be to specify your flow and shut-in points. And again, because we have those water rates and pressures contained in the same file, they're already synchronized. Okay, so the next step is going to be to specify the start of injection line. So I'm going to maximize this chart. And we're going to take a look at the early time data a little more closely. And then by selecting this start of injection line, we're looking for the point at which the well bore is filled with water and we're starting to increase the pressure to crack the rock. And so that would be right around this point where we see a sort of a linear response coming up to that large increase in pressure when we've actually completed filling the well bore and we're actually starting to increase the pressure in there. After we've specified our start of injection, we're going to go ahead and enter in our PVT properties. And first step is to select the reservoir fluid type, which in this case is gas. And we're going to go ahead and do some filtering of the data. And in this case, we're going to keep the default filters active. For the fall-off period, which we're most interested in, we're going to be doing logarithmic cycling, and we're going to be reducing that data set from about 12,000 points down to 875. And that's just going to make it a little more easy to manage in the software. So now we're going to enter in the rest of the PVT properties. So our reservoir temperature was 76 degrees. And we're going to go ahead and leave this reservoir pressure defaulted. It automatically will go and pick the appropriate pressure from the data. And our gas gravity is 0.6. And we do have some nitrogen, 2%, and some carbon dioxide. So now that we've entered in all our PVT properties, we're going to go ahead and set up our well bore so we can convert our wellhead pressures down to bottom hole pressure. So we're going to go ahead and select next here. It'll bring up our wellbore calculations box. And it's already defaulted to use the pressure from the casing. And we are doing a mini frac test and injecting water, so we have the appropriate fluid selected here. And now we have to specify a little bit more about our wellbore. In this case, we have an MPP depth of 2,000 meters. And our casing depth is at 2,100 meters. And we also have the ability to enter in a deviation survey if necessary, or to switch to a different pressure loss correlation if necessary as well. But for this case, we have neither of those. So we've set up our wellbore, and in order to do the calculations, we'll hit calculate. And now you'll see we have the original casing pressures and our calculated sand face pressures available to us in the production editor.